All right. So let's say we're tasked with the problem of solving these two systems of equations. So the important thing to notice here is that these two have the same coefficient matrix. In other words, the left sides of the equations are all the same. So this is a situation in which the matrix approach to this can help us out. So what I'm going to do here is set ourselves up. Remember a matrix equation for this is of the form AX equals B. So here the A is the same for both of these. The X is the same. The B part of these, we'll say B sub A is for this first one. B sub B is for the second one. Right? So for the first equation, we're trying to solve AX equals BA, and the second one is AX equals BB. If we solve this system of equations, or if we solve this using matrices, we're in a situation like this. Now the interesting thing here to notice is that both of these have A inverse in it. It's just A inverse times this constant vector here. So if we find A inverse, then all we have to do is just multiply it by all of the constant vectors. We could have 5 different systems of equations here, and all we would have to do is just take those constant parts and keep multiplying it by A inverse. So let's do the work of finding A inverse here. I'll actually just sort of, write all these steps down here. So doing the work to find the inverse, remember we take the matrix A and we adjoin the identity here. So, and we do row operations to get the identity over here, and then this is A inverse. All right. So in this case, A inverse is going to be 1/2, 1/2, 1/4, minus 1/4. All right. So now we can just solve for the solutions here. So for part A, X is going to be this inverse matrix times the constant vector, which for BA was -1, 3. Right? And so we just write this out. This will be minus 1/2 plus 3/2 for the first one, and minus 1/4 minus 3/4 for the second one. Right? And that's going to be 1 minus 1. Right? For part B here, X is, we got 1/2, 1/4, 1/2, minus 1/4. Okay. And then let's see, B is 10 minus 6. So 10 minus 6. Right? And then we just compute this. So 10 times 1/2 is 5. -6 times 1/2 is minus 3. 10 times 1/4 is 5/2. -6 times -1/2 is plus 3/2. And so we get 2, and then this one will be 4. Right? So we can start pumping out solutions really quickly. Okay? So, with that in mind, why might you want to do this? Like, when would a situation where you keep wanting to change the constant parts of these systems of equations? Well, this can be used in a lot of models. Say you have like production models that you need to meet, right? You might want to, test around different scenarios of like production levels and things like that. So there are situations, there are applications in which you would have the same kind of variable setup, but you want to change the constant parameters. And doing this with a matrix inverse is really great. Plus, as you'll see, there's actually a shortcut for computing some 2x2 inverses as well. All right. So with that, we'll wrap this up here. And we'll see you in the next one. We'll start talking about some elementary matrices.